It's 8:30. Okay, cool. Well, good morning. I'm Radovanovic, and today I'm excited to introduce Oral Talk Session 17, Education. Across our 5 talks, we explore a range of perspectives on education, including how features of learners, such as knowledge and source, features of teachers, such as knowledge and source, and features of learners, like gender, inhibitory, and control, relate to learning and motivation. Not only will you hear about variability in learner and teacher, but I also hear how the content itself can be modeled and understood. Altogether, I hope this set of 5 talks will provide you a well-rounded developmental perspective, with participants ranging from the elementary years to high school. For our first talk, I'll present on gender differences in elementary-age children's ability to detect and divest from inaccurate teaching. For our second talk, Adam John Privatera presents cross-cultural evidence that inhibitory control predicts academic performance above and beyond IQ in a sample of Chinese high schoolers. This will be followed by Mika Asaba's talk, which presents evidence that middle and high schoolers value encouragement from those who know both them and the content matter well. Next, Megan Merrick will present how differences in feedback source, computer-based or person-based, relate to mathematics performance. And along this theme of mathematics, Dr. David Braithwaite will conclude our session by presenting a model which unifies an understanding of decimal and fractional arithmetic. So again, I'm going to present work I've done looking at gender differences in children's ability to detect inaccurate teaching. But before I start, I do want to note the dynamics that I discuss are likely relevant to transgender people, but I only discuss boys and girls because of the features of our sample. So starting from the basics, we know that teaching is an integral part of learning. Teaching has strong attentional cues like eye gaze and pointing that allow information to be transmitted efficiently. And teachers also allow us to learn things that would be extremely difficult to learn all alone, like programming. Because of this importance, we make assumptions about teaching. For example, we assume that teaching is complete. So if a teacher teaches us about an object, we assume they've told us everything we need to know, and we're less likely to explore it ourselves. Likewise, in over-imitation studies, where there aren't clear goal-directed reasons for why certain steps are being performed, we still see that people copy these steps, assuming that there's a cultural or social purpose instead. So this is all to say that teaching is critical for our learning and generally informative, and because of that, we make certain rational assumptions about informativeness and reliability. But what about the instances where teaching isn't reliable? What happens under these circumstances? There's some evidence to suggest that children reason critically about teaching when they're provided with explicit cues to detect reliability. So for example, even preschool-aged children will choose to learn new object labels from an informant that had been previously accurate over those that were previously inaccurate. Preschoolers will explore more when a teacher had been previously under-informative relative to completely informative. And elementary schoolers will explore more when provided with counterintuitive rather than intuitive claims. However, in the real world, overt cues aren't always present. We know that structural issues permeate education systems. I'll focus on the United States here, but this is also true for Canada and many other countries. So this is to say that there are times where political agendas or the status quo lead to accurate information being filtered out and being replaced by politically desirable information instead. And because this information is passed down from one generation to another, teachers aren't necessarily aware of the inaccuracies that they're passing on because they were taught in these same traditions themselves. And even in the instances where teachers are aware, they may not be allowed to indicate these inaccuracies out of fear of losing their jobs. And when these issues intersect with gender marginalization, there are greater consequences for girls than boys. So for example, in the United States, sexual education has been very politicized for decades to the point that many states don't have accurate curricula. And while this is harmful for children of all genders, girls and people assigned female at birth will disproportionately face the harms of unwanted pregnancy and sexually transmitted infections. So the data I present today will be much less serious and in a much more playful context, but I think this example is important for illustrating that we often take for granted that teaching is accurate, but children are dealing with very real circumstances where teaching is inaccurate. And we would hope that children are able to detect these inaccuracies and find better solutions, especially in some cases, girls. That said, in these situations, children must be able to generate their own counter evidence and then explore other options. And this method of assessing teaching accuracy will be more challenging when overt cues are present because there's an inherent level of ambiguity. So in these situations, we have to ask ourselves what the probability is that the evidence we generated is more correct than what was presented to us by teachers, and then decide what our personal threshold for acting on this evidence is. So it could just be the case that we misunderstood or that our experiences were anomalies, And even when we are correct, we may not want to take on the emotional burden of challenging authority figures or standing out. And it's because of this ambiguity that we may see a paradox in which identifying incorrect teaching will at least sometimes be particularly necessary for girls, but the way that girls are socialized discourages prioritizing their own ideas and standing out. So we know from past work that girls are socialized to feel more responsible for the emotions of others, even as toddlers, and are more likely to engage in comforting and people-pleasing behaviors. Likewise, as children age, we know that girls and women are more likely to avoid self-promotion and standing out relative to boys and men for fear of negative consequences. And these dynamics may be particularly salient in educational contexts. I want to emphasize that girls tend to do well in school and generally outperform boys using metrics like GPA and SAT scores, but there are associations between gender and conformity that are especially stark in the classroom. So for instance, teachers have rated boys as more nonconforming than girls, and even when they're praising students, they're more likely to emphasize girls' obedience while highlighting boys' nonconformity and independence. So the main tension in this work is that girls are simultaneously encouraged to conform and not hurt other people's feelings, which may make girls less likely to identify incorrect teaching and less likely to act on the knowledge that is incorrect, despite it being particularly important, at least sometimes, for them to do both things. So this led me to formalize two research questions. First, at the global level, I wanted to ask whether children could identify inaccurate teaching in the absence of explicit cues, because no one to our knowledge had done this before. And second, I wanted to interrogate whether there were gender differences in this ability. So to answer this question, we tested children aged 7 to 10 years old. We wanted to span the elementary years, but we started with 7-year-olds because we knew that certain gender stereotypes should already be present, and because we wanted our gig to be developmentally appropriate for our entire sample. In total, the sample included 150 participants, so this was a highly powered sample based on preliminary data, and 76 participants identified as girls. Notably, children could identify as non-binary, we just didn't have any non-binary participants. And I brought up some serious context where these problems may play out in the real world, but because this concept was relatively understudied, we started with a more conceptual cognitive paradigm. So children were introduced to a 2D platforming game over Zoom, in which the goal was to find a trophy to win. The study started with a practice, ensuring everyone had sufficient knowledge of the game controls. Next, children received a video instructing them on how to find a trophy. Critically, the solution shown in the video didn't work in the test game that children played because we removed necessary platforms. So this was the video that children were shown. I removed the audio here so that I can talk, but there was a little bit of audio at the beginning and the end of the video where they could hear a teacher's voice. So we wanted to make sure that if we did see differences between girls and boys, that it wasn't simply that girls were more likely to match a female voice. So girls were instructed by a woman and boys were instructed by a man. And you can see that from the video that the path that the frog follows is fairly linear until it gets to this area. So this is the critical area that will differ from the instructional video in the test game. To zoom out a little bit, you can see the whole map here. So this was the area that I mentioned where the solution fails in the game, but not in the video. So to succeed, children had to first test the solution, and then divest from it by exploring to find either of these two alternative trophies. We performed coding to classify children's ability to generate evidence that the solution was ineffective, and then also to classify how they allocated their time between exploration and imitation. So here on the left, you can see what the game in the instructional video looks like, and like I mentioned, on the right, there are missing platforms in the version that children played during test. So children can test the solution by getting to this part of the game and making a full jump, showing them that they don't have the height required to clear the top. And at this point, children should have evidence that the solution won't work, whether or not they're confident enough to act on that evidence. We also coded the amount of time they spent imitating by looking to see how much time was spent in this region of the game map, so this is the same as the instructional video, and then how much time was spent exploring these areas which were not in the video. And importantly, the exploration and imitation time was divided before and after testing, because we would expect that rationally these behaviors would differ. So initially it makes sense to copy the teacher, you have no reason to think the instructions won't be correct, and then after testing you should gradually divest from it. We were able to get a measure of success by looking to see whether they got the trophy on time, but we also wanted a measure of learning. So they were shown these 4 areas, some that were in the game, some that weren't, and asked if they were part of the game that they had played. And of course, these are search questions, so they should be very linked to exploration, but I'd love to talk more about different questions that we could have asked. Getting into the actual hypotheses, we first wanted to see whether children engaged with the instruction. So we thought as a group, children would test the taught solution, since children tend to do well in exploratory environments. And we also didn't expect any gender differences at this stage, because divesting from instruction wouldn't be necessary. And if anything, we thought girls might be more likely to test and outperform boys in this measure, since they tend to do better academically and maybe better at replicating teacher instructions. And second, we thought that those who prioritized exploration after testing would be more likely to succeed. So here on the x-axis, you see girls and boys, and on the y-axis, the proportion that tested the taught solution. Here we use 50% as a sort of rule of thumb chance reference, since they could either 0, not test, or 1, test. And we see that both groups are over chance, and that there's also no gender difference in testing behavior. Here on the x-axis instead, you have whether children solve the game, yes or no, and on the y-axis, the proportion of time exploring after testing the taught solution. And you do see that those who solved the game explored more after testing. And likewise, the proportion of time exploring after testing was correlated with the number of correct areas that children identified when asked the learning questions. So we do see that as a group, children are able to test, and also that those who prioritized exploration succeeded more, both in terms of solving and learning. Going specifically into the gender-based hypotheses, we expected the differences would really begin at the point at which children had to divest from teaching. So specifically, that girls would explore less than boys after testing, and that these differences in exploration would lead to downstream consequences in success, so both solving and learning. So for the next set of graphs, the x-axis is always participant gender, and the y-axis will change based on the variable I'm describing. Importantly, all of these analyses control for age and video game experience, so any differences we see are above and beyond skill differences. So we do see that girls spend less time exploring after testing. We also see that girls are less likely to solve, and that girls answered fewer learning questions correctly at the end of the study. So we did see that girls explored proportionally less, and it's led to downstream consequences in terms of their success outcomes, both solving and learning. However, before concluding these analyses, we wanted to make sure that these differences were specifically because girls were less likely to test their own solutions. So we ran 2 mediation models to confirm this pathway. And indeed, these data reveal that differences in solving and learning were both mediated by differences in the proportion of time spent exploring after testing the taught solution. So it seems that girls were disadvantaged in this setting, specifically because they did not explore their own solutions as much as boys did. So putting this all together, even with multiple controls, we saw that girls explored less than boys, and this led to an achievement gap in terms of success in learning. And the fact that we were able to see differences in both achievement measures suggests that there may be short-term and medium-term implications to these patterns. Importantly, when I showed you that testing data, we saw that there weren't differences in testing ability, and we also used multiple controls to account for superficial differences between boys and girls. So it seems that the disadvantages for girls really begin at the point at which they have to divest from the teacher and not based on simple skill or competence. And while this data is quite preliminary and needs to be expanded in context and age, one promising component of it is that it may be able to guide questions about ubiquitous gender differences. So across almost all industries, including those perceived as women-dominated, like education and psychology, women are overrepresented at entry levels relative to leadership levels. And obviously, this is a multifaceted problem with multiple sources, but one component may be that even as girls, women are discouraged from pushing their own ideas and correcting other people, which may be necessary components of being a leader. However, in this vein, I would like to point out some viewpoints that are excluded from the current work that we want to expand in the future. So first, I want to contextualize the behavior that we saw from girls in our sample as an adaptation. So in this setting, the solution was completely incorrect and there were no alternatives. But had the solution simply been ineffective, or there hadn't been alternatives that they could use to solve the game, the solution may have actually benefited girls, and we might have seen them outperforming boys. For this reason, we're currently in the process of performing some additional coding to quantify girls' persistence. And we controlled for differences in video gaming skill, but of course, video games are traditionally viewed as masculine, so it may be possible that children were sensitive to this, and that these gender differences may not persist in more neutral or feminine stereotyped contexts. So we hope to disentangle this in future work. And finally, I focus on differences between boys and girls in the sample, but these skills are likely relevant to people with a variety of marginalized identities. And likewise, those with intersectional identities, like Black girls, may not be equally benefited by people-pleasing and may have different gender stereotypes, so this work should be generalized with caution. But this project was the first step in what I hope will be a much longer line of work, so hopefully we'll have data from increasingly ecologically valid contexts for a more nuanced picture. But with all that said, I want to thank my collaborators, most importantly Ajay Ujar and Dr. Jessica Somerville, and many research assistants who processed this data in the last 2 years. I'm excited to hear your questions.